Hi friends, good evening. So welcome to the marketing analytics trainings by 360DigiTMG. So in the previous classes, so we have discussed about applications of marketing analytics. Then we discussed CRISP MLQ methodology. After what is EDA and pre-processing. Then we discussed about unsupervised learning. Then KNN, and yesterday we discussed about decision tree. So already we know machine learning classified into the various types. So supervised learning and unsupervised are the main types. So in the supervised learning, so again it is divided into two types. So one comes under classification models. And next one is regression. So yesterday we discussed about decision tree, which comes under classification model. So today try to discuss what is regression in machine learning. So regression is nothing but regression is a statistical method to give relationship between dependent variable and independent variable. So the independent variables are one or more independent variables. So relation between which gives the relationship between a dependent variable and so one or more independent variables. Yeah, relationship between one dependent and so dependent variable we will say that is target variable, and independent variables are nothing but predictors. And the regression helps us to understand how the dependent variable is changing corresponding to the independent variable. So how the output is changing with respect to the independent variables. So that is nothing but regression analysis. So in the regression analysis today we have taken a linear regression. So in the linear regression we will discuss simple linear regression today. In linear regression, so it shows a linear relationship between dependent variable and one or more independent variable. Dependent variable is nothing but y. The relationship between y with respect to the independent variable. The independent variables are either one or more. And mathematically, so we can represent equation that is y is equal to, can say a naught. Okay, a naught plus a1 x plus sigma. So this is nothing but one random error, right? Simply I'm writing sigma. So where y is nothing but a naught x, a naught plus a1 x plus a2 x square, like so. This is about regression equation. So y is nothing but dependent variable, output variable, and x is nothing but independent variable. So regression, linear regression, which gives a relationship between one dependent variable with respect to one or more independent variables. Now let us discuss about today's agenda. Yeah. So today we will try to discuss the introduction part for simple linear introduction for this concept and linear regression in machine learning and importance in marketing analytics, and finally we'll conclude our session. Coming to introduction, so it is easiest and most popular machine learning algorithm, and it is for predictive analysis. So if we have the data, we can predict for future. And linear regression makes predictions for continuous or numeric variables such as sales, salary, what will be the future, sales, age, product price, etc. And there is a line which is giving the relationship between dependent variable and independent variable. Now let us discuss simple linear regression in machine learning. So simple linear regression means in linear regression, it will give the relationship between So linear regression will give the relation between one dependent variable and one or more independent variable. Coming to the simple linear regression, the simple linear regression, so it will give the relationship between a dependent variable and a single independent variable. So there will be one independent variable, one dependent variable. So the dependent variable is nothing but y, and the independent variable is nothing but x. And the relation between these two is nothing but straight line. And simple linear regression has mainly two objectives. So the two objectives of simple linear regression are, so first one is we will model the relationship between the two variables. And first we'll give the relationship between the two variables. One is independent, one is dependent. The relationship will be, you can take examples as relationship between like income, expenditure, experience, and salary. So we will give relationship between what is the income and experience, or we can take experience versus salary. So these are the two examples. So to apply linear regression concept. So first we will give the relationship between independent variable and dependent variable. And second case is nothing but forecasting new observations. Second is nothing but forecasting new observations. So it has two objectives. So first objective is nothing but model the relationship between two variables, like the relationship between one dependent variable, another is independent variable. You can take examples as income and expenditure and experience and salary. So this is the first objective. And second objective is we can forecasting the new observation. Like suppose we have the data. So the data having the two columns. One column is nothing but expenditure. Okay, this is now okay. You can take expenditure. Yeah. So we have two columns, expenditure and salary. And if we have the salary, just we can predict what will be the expenditure, like, or vice versa. Yes. So in future, we can forecast. So of what data values we have, just with that, in future, what will be the salary or what will be the income, we can forecast. So these are the two objectives of simple linear regression. Next, how to implement simple linear regression. And before that, it is a regression algorithm that model relationship between independent and single independent variable. And next, the relationship shown by this regression model is linear or slopeful. And these are the two objectives. Yes. Next, how to implement this. So how to implement the simple linear regression. So for implementing, we need to focus some points. First step is the thing. So we want to find out there is any correlation between these two variables for implementing simple linear regression. So first step is the thing that we need to check, find out if there is any correlation. So generally the correlation values will range from -1 to +1. Next, after finding the correlation, so best fit line for the data set. So what should be the best fit line for taking the various data point, and what regression line is best fit for our model, we need to check. So then we need to find out how the dependent variable is changing, how dependent is changing with respect to independent. Yes. So these concepts we need to consider. And for implementing linear regression for our data set, just these are the steps we will follow. So first thing is data pre-processing. So data pre-processing, I already explained. So data pre-processing comes under. So first we need to analyze the data. So in our data, if we have any outliers, so we need to remove the outlier, or we need to make outliers as non-outlier. Some methods are there. Normally, if the data set size is more, if the size of outliers is less, we simply use drop NA method. So that is one of the method. And another thing is, if we have NA values, the outliers we need to adjust, and if we have NA values, so we need to use drop NA method. Okay, just I'm correcting the sentence. Outliers, if we have, we can make that outliers as non-outliers. Similarly, if our data set having NA values and we need to remove NA values, or just we can write a logical value. If the data set size is more and NA values are less, so in that case we can simply use drop NA method to work with NAs. Suppose if our data set size is less, in that cases you can add some logical values, mean imputation, median imputation. So this some methods are there With that methods, we need to fix that values. So after what we need to do, just we need to fit the simple linear regression on the training set. Yeah, we will split like training 80%, testing 20%. Then we will predict the test results and finally visualizing the training results and visualizing the test results. So these steps we will follow. So this I can explain by hands-on, not a problem. Next, how the regression is. The importance of regression in marketing analytics. So regression analysis is another tool for market research firms used on a daily basis. So what type of brands the people ready to purchase? We can take some example. Just in a shopping mall, we have various brands. In a month of June, the people are purchasing only brand A. Brand B is less, C also less. So based on that, next month they can take a business decision so that the brand A, so that is mostly it is attracting, the brand is attracting by the people. So let us invest more money on A. So like that. So A we can forecast. So next month people will purchase brand A items, like. And the benefit of using third-party market research is that you can so their expectations on particular data. So this also will be done by the regression analysis, and it is help us to most impact and influence on your customer relationship. So this will be done in the marketing analytics with regression concept. Now coming to the conclusion, just regression analysis is a great tool for predictive analytics. We can predict what will be the output in future and forecasting in market research. So forecasting results. So what will be the output in future? Either whatever you can take, what should be the TV sales in the next month? What will be how much amount will spent by the customers in the next month? Yes. So we can do forecasting with the regression concept, and it helps businesses and organizations prioritize efforts to improve measures like overall satisfaction, likelihood to recommend, or net promoter to score, NPS, net promoter score. So it is the regression, this linear regression. So we'll suggest organizations and business. So what effort you need to take to improve your measures for satisfaction? What steps they need to take to improve their business? So it will give good idea. Yeah, it is also helpful. This analysis is helpful to improve the overall satisfaction of the customers. Okay, so this is about simple linear regression. So let us implement this regression analysis on Jupyter. Yes. So sales prediction. So the problem statement is nothing but build a model which predicts sales based on money spent on different platforms for marketing. So predict sales based on money spent. So this is the problem statement. And here using the data set advertisement, so we can analyze the relationship between TV advertising and sales. How the advertising impact or improve the sales. So using simple linear regression model in this node. Okay, we will build a linear regression model to predict sales. So using an appropriate predictor variable. So output variable is nothing but sales. Let us rerun this. Yeah, first of all, I'm importing import warnings. So because while I'm executing this code, I may get some warning, just I want to ignore. So I'm using import warnings or warning.filter warnings ignore. And I'm importing the necessary libraries. So NumPy and Pandas. So NumPy, it is generally work with arrays and for data analysis. And Pandas also use it to, it is important, it is essential for data analysis to load the data and etc. To do some analysis. Pandas is compulsory. And similarly, data visualization. For data visualization, we are importing matplotlib pyplot as PLT and cban both for visualizations. So matplotlib.pyplot as PLT, meaning in next lines, instead of matplotlib.pyplot, simply we can write PLT. Like pandas also we can write PD. Yes, I am executing this. Yeah, it is fine. Now this is the time to load the data set. So pd.dataframe read underscore csv. And after loading the data set, just I want to know the top 5 rows. So to get top 5 rows, we need to execute the command. So advertising.head. Yes. So this is the data set. Here the column names are TV, radio, newspaper, and sales. So here our independent variable is TV and dependent variable is nothing but sales. And again, I am explaining about auto EDA. So auto exploratory data analysis. So I'm using the package that is called Pandas profiling. So Pandas profiling is helpful to do auto EDA. So auto EDA, generally it is helpful to do what steps I need to take for next, what things I need to implement. Just I can get overall view of my data set. So let us execute this. Yeah, it is done. So I want to show the file. This is the report. So it is giving information, data set statistics. So number of variables 4, number of observation 200, missing cells 0, and missing cells percentage 0.0, and no duplicate rows. Duplicate rows percentage also 0, memory size and average record size in memory. Next, coming to variables, TV. distinct value is 190, distinct percent is 95. Yeah, missing 0. So that is a univariate analysis on T. So mean, minimum, maximum zeros. Next, radio column, newspaper, and also sales. Next, interactions. So with respect to TV and TV, yeah, radio, TV. This TV with respect to TV, radio with respect to TV, yeah, newspaper with respect to TV, yeah, sales with respect to TV. So here, these are the data points we have. Our target also to fit a regression line, simple linear regression line between sales and TV, so that I can predict what will be the sales for particular TV. Yeah. So correlations. So missing value. Yes, first dose, last dose. Yeah. And here you can warning, sales is highly correlated with TV. High correlation between sales and TV, and TV is correlated with, okay, that is a warning. Yes, so this is auto EDA report. So let's go to our code. And here some points I want to explain about error calculation. So a regression problem, just we will do error calculation. So how we will do in error calculation, linear regression model. So in linear regression, most often uses mean square error. Mean square error. So mean square error is used to calculate the error of the model. We use mean square error to calculate the error of the model. So this MSC, mean square error, also called as MSC. So MSC is calculated by measuring the distances of the observed y values from the predicted y values. So we will find the differences. Measure distances of observed y values from the predicted y values with each value of x, like y minus y1 for each value of x. And next step, what we will do, squaring each of these distances and calculating the mean of the square distances. So MSC we will use, and one more error we can have, RMSC. So RMSC is nothing but computed by taking the square root of MSC. So MSC square will give RMSC values. Next we have R square also, R squared value, R squared. So R square is nothing but how much variation of a dependent variable. So this is explained by the independent variable. So R square will give how much variation of a dependent variable is explained by explained by independent variable. The next one more thing is p-value. P-value also we use. P-value also will give the relationship between the variables, and generally the p-value is lower than 0.05. Yes. Okay, let us. These two are very important to understand this analysis. Next, so auto exploratory data analysis is finished. So data inspection. So what is the shape of our data set? Let us execute. So it is having 200 rows and 4 columns. And next, if I to know the information, advertising.info, just what columns we have, so we will get information regarding each and every column after executing this. So we have the columns like TV, radio, newspaper, and sales. So data types is given, and describe. So statistical analysis it will do, advertising.describe. Yes. Next, auto EDA is done. Now we are going with first. Do we have any null values or not? Yeah. So TV, radio, newspaper, and sales. So in no NA values. So already we have seen no NA values. That's why auto EDA will give the idea of our data set. Next, outlier analysis. Do we have outliers on box plot? We have outliers in the newspaper. So okay, no considerable outlier present in the data. So because we are going to give the relationship between sales versus TV. So no outliers, fine. Next, exploratory data analysis. So we are starting with univariate analysis. So sales anyway, that is our target variable. Just SNS for visualization. Already that we imported. Box plot, it is fine. So let's see how sales are related with other variables using scatter plot. Okay, just this is scatter plot will give how the sales is related with respect to remaining 3. So remaining 3 is nothing but TV, newspaper, and radio. Yes. This is a scatter plot. So TV versus sale, and newspaper versus sales, and radio versus sales. Next. So let us see the correlation between the different values. Just it is for some colors. Yeah. So now our data. So we have finished auto EDA and EDA is completed. So data pre-processing also finished. So let's go to the model building part. So here some information I have given. Equation of the linear regression. C plus M1x1 plus M2x2 and so on MNx. So Y is the response, C is the intercept, coefficient of first feature, second feature. Other case we can write here Y is equal to C plus M1 into TV. So TV is the independent variable and Y is the dependent variable. So Y is depending on TV. So sales depending on TVs. So TV is independent. So we will predict sales with respect to TV. So some steps. So we first assign feature variables. So in this case, the variable is X and the response variable sales to the value. So here, yeah, as our concept is simple linear regression, we will give the relationship between TV and sales, and Y is nothing but sales. X is nothing but T. Done. Next, train test split. So you need to split our variable into training and testing. You will perform this by this train test split. We need to import from sklearn model selection library. So it is good practice. 70% of data. Okay, generally 70-30 you can take, 80-20 also fine. So here we are taking 70% training and 30% testing, meaning so out of total data, just we will take 70% of data, we will train the model and we will test with the remaining data so that we can compare. Yeah, from sklearn model selection, import train test split. Yeah, 0.7, 0.3 random state 100. And what is the train? Yeah, so training values, train head. TV versus sales values on that. Next, building a linear model. To build the model, we need to import if you library using, you will perform the linear regression. So start model.api as this. So start models, it is a line on the data set which passes through the origin. So in order to have, because in ideal cases, the line will pass through the origin, but if you have the intercept, the line will be passes through the intercept on x-axis. Yeah. So to get a constant value like y is equal to mx plus 6, some intercept if you have, you will get one constant value. So find the parameter intercept and the slope of the regression. Constant value and the t. Yes. So performing a summary operation, list out all the different parameters. Summary of so dependent variable sales, that is y, OLS model. So least squares, date and etc. This is the regression results, coefficient values, error, etc. So here standard errors now assumes that covariance matrix of the error is correctly specified. Now looking at some key statistics from the summary, the values we are concerned with the coefficients and significance, p values and r squared value. I already explained r squared is nothing but how much variation of a dependent variable, how much variation the dependent variable is explained by the independent variable. Yeah, coefficient TV 0.054 and r squared 0.816, meaning that 81% of variance is sales explained by the team. 81% sales are explained by the TV. This is a decent value. It's fine. So practically low, meaning the model is statistically significant and explained variance is not purely by chance. Now the fit is significant. Let's visualize how. So sales is output is equal to 6.948 plus 0.054 into T. Now scatter plot. Yeah, so model building is done. So what should be the best fit we need to choose? So this is about residual analysis and distribution of the error terms. So what should be the error we are calculating here? So train prediction. Yeah. So error terms. So the residuals are following are normally distributed with mean zero all good. So residuals is nothing but the difference between actual y value to the predicted y value. And here if the residual is negative, the predicted value is high, and similarly if you have the positive residual, meaning predicted value is low. So residuals are nothing but difference between actual y to the predicted y. So looking for the scatter plot. Now predictions, okay, training is done, predictions on the test set, 20% data. Yeah, these are the predictions. And mean squared error we calculate. I already explained mean squared error. So based on that, we can evaluate our model performance. So here RMSE is nothing but square root of the mean square. It is 2.10. Checking R squared on the test data. Yeah. So test data, it is giving so 0.79. So generally this R square 0.79. We can say the model is okay. Cannot say it is excellent and fit on test data. So here what we did here, just it is a simple mathematical model. In simple regression, we have one dependent variable and one independent variable. And what data we have, just we will simply split into training and test. We will apply the algorithm. Then after applying that, in future, based on this algorithm, then in future we will send the data. So if you in future, what will be the output? What should be the sales in the next month or next year and etc. That can be done by this algorithm. This is okay. This is a simple linear regression. Just once again, revise the topic what we discussed. And today we discussed about the introduction part. So what is regression and what is linear regression in the machine learning and how it is important in marketing analytics. Now coming to the introduction part. So it is this is the easiest and a popular machine learning algorithm. It is a statistical method for predict forecast etc. in future. Now these are the examples like sales, salary, age, product, price. And linear regression, it will give a relation between one dependent variable with respect to one or more independent variables. So we have types of linear regression. In simple linear regression, what we will do, we will give the relationship between independent variable and dependent variable. If the independent variables are more than one, then we go for multiple linear regression. And simple linear regression, machine learning. So it is a very simple algorithm, simple concept. We have two columns. One is dependent, another is independent. Just we will try to keep the relation between these two. So the two will be like income and expenditure. So we can take income will be the output variable and expenditure is independent. We can predict what will be the income, so based on expenditure. Similarly, experience and salary is nothing but you can take as dependent variable. So experience you take as independent variable. So we can find the salary based on the person experience. Like some persons, they are having 2 years of experience. What will be their salary? The persons are having 5 years of experience. So what will be the salary, etc. And how to implement, just already I have implemented in the Jupyter notebook. First, we need to load the data. After loading the data, just we will do some EDA for graphical analysis. After data pre-processing, nothing but two concepts, whether we have in-year values or we have outliers and etc. We need to fix that issues. Then splitting our data into train and test, and then go with the visualizations. So how the regression in marketing analytics, just to predict, or we can take a number of examples. So what will be the sales of a particular product, we can predict, and based on that, okay, if maybe in future, last 1 month, so people are using some product. So what we can do, just we can invest our business on that product so that we will get. So in this way, the regression concept helpful in the marketing analytics. And as I said, it is the great tool for predictive analytics and forecasting in market research analysis. And it will give the idea just what the precaution, what steps I need to follow to improve my business. Some information it will give. Okay. Yeah. So thank you, friends. So this is about simple linear regression. Yeah. So thank you very much, and please subscribe our channel. Bye. Have a nice day.